Hey folks, this is Michael speaking, and today I want to talk to you about some perspective problems that I had and how I found the solution. And it kind of was pretty cool, so I'm hoping that you'll find it useful in some of your own stuff. And yeah, that's it. So what I was trying to figure out is I had a scene, a typical two-point perspective scene, and if you're familiar with two-point perspective, there's a horizon, you might have a vanishing point here, vanishing point there. You've got some lines, and you've used those to make a square or a rectangle. And what I was trying to figure out is, okay, given that, let's say this is north and this is west, because that's a 90-degree angle, where should northwest be? Where should northeast be? I wanted to do other vanishing points to try and make a nice geometric shape, and I needed to know where those compass headings were. And I didn't know how to do it, and I tried it, and I got myself into some trouble, and it was pretty funny. And so what I want to do is take you through the wrong way to do it. I want to take you through some of the roots of linear perspective when I was trying to figure out what the right way would be, a quick formula to work it out, and then a shortcut which lets you do some pretty neat things. So let me start from the beginning. Just get a clean layer to work on. So I had a scene and it was pretty much like this. Camera's pointing this direction, and we'll call that north, and our horizon going this way. And let's say northeast is over here, northwest is over here. So what I want to know is, well, if you can remember your compass headings, so let's do a little refresher here. North is this way, looking down from above. Then that means east is 90 degrees, west is 270 or minus 90. Then northeast is 45, and northwest is 315 degrees or minus 45 degrees. So my scene looked a little like this. I'm looking north through a garden, and I've got a garden path that comes from the northeast like this, and I have a path from the northwest. Now, okay, I've got 4 paths, and what I wanted to do is add 2 more. I wanted to add in the diagonals. So, okay, the first 2 diagonals are really easy. Coming from the north, I can just draw another path coming this way, and because of the geometry of a square, this path is actually slightly wider than the other 2. But this is a simple 1-point perspective setup, and these are from the 2-point perspective. And when I want to do my east-west path, because I'm looking north, that just goes straight sideways like this. Oops. So that's very straightforward. The difficulty was, one, I wanted to have 16 paths. I wanted to bisect this angle. And now you can see on my diagram these are 5 inches apart. So at 2.5 inches, that would be about here. So naively, I just thought, okay, that'll go over here like that, right? No problem. And I'll do the same thing on the other side. And then my difficulty came when I wanted to figure out where east-northeast should be. What I did when I figured out where north-northeast should be is I took the distance between north and northeast and I cut it in half. And obviously that's not right, because when I come to cut the distance between northeast and east in half, to try to find this angle, I can't do that because east is straight this way. It's actually an infinite distance over here. This line will never meet the horizon, no matter how far I draw it. So there's no way to do that. So, well, I wasn't going to be deterred by that problem. So what I noticed was that, okay, look, if this is 2.5 inches, and that's 5 inches. If it's 5 inches to go from north to northeast, then that means 5 inches equals 45 degrees, right? So if I want to go all the way from northeast to east, then that would be another 5 inches. So east would be there, and 2.5 inches over, I should have my east-northeast. Okay, seems very reasonable, but the problem is I can't have an east vanishing point if east is over here. I've already broken my perspective, so this assumption is clearly wrong and it's going to produce some pretty weird results. I can't have 2 vanishing points for the same direction. So what is going on? So let me tell you a little bit about basic perspective. So in linear perspective, you've got a viewer. There's a nice viewer, and this is the artist facing away from us, whose eye is going to be there on the back side of his body, and he's looking at a scene. Let's say it's a square, something simple like that. So everything in linear perspective is based on the idea that there's an invisible pane of glass hanging between the artist, the viewer, and the scene, and you're tracing the scene on that pane of glass. So something like that. So you take lines from the viewer's eye and you draw them out to these regions, and wherever they cross oops, I'm drawing it too small. Too big, I mean. Right? So this is the entire basis of linear perspective. I'm going to redraw this again from the top to show you something interesting. So here's the viewer's head. There's the one cyclops eye that they're squinting through to see what's in front of them. And then here's an object that they want to capture on their canvas. And I'll lay down the imaginary pane of glass. And this is the viewer looking straight ahead at the pane of glass. So this is like the viewing ray, the center of the picture. So I'm going to lay down some other angles. Out of the corner of their eye, they might be able to see some fuzzy stuff to the east. There's 45 degrees. There's about 22.5. There's 67.5, cutting that in half. So what I hope you can see from this is my assumption that if you go a constant angle to the right, because these angles are all the same basically, you'd go a constant distance to the right on the canvas. That's completely wrong. You can see that pretty clearly here. This distance is smaller than this distance, which is smaller than this distance. And to take that last step, you'd have to go an infinite distance, because this line here never meets the horizon. So this led me to an understanding of the math behind where things appear on the canvas depending on the angle. So if this is 45 degrees and it's this far from the center of my picture, and this is 22.5 degrees and it's this far from the center of my picture, what's the formula to tell me exactly how far to go for whatever angle I happen to be looking at? So it turns out that formula is relatively simple, but I need to know 3 things. I need to know, given my picture, I need to know where the center of my picture is. Where's the viewing angle? Where is the shortest distance to the imaginary pane of glass? And as you saw, because the angles are different in different places of your picture, you have to know where that is. If you start cropping your picture, you're still going to have some remnant of the original perspective. So I have to know where is the center of my picture. Secondly, I need to know what's the field of view of my picture. So the field of view is how much of the scene am I seeing. So if I've got a wide angle lens, I might be seeing a wide scene like this. If I'm looking through a sniper scope, I might only be seeing half a degree. For a typical scene, I might be seeing 90 degrees, something like that. And the way you express that is, what is the distance on my canvas to 45 degrees? So if I'm looking at the center of my picture, down here, and I want to look 45 degrees to the right, where is that? And I can just put that anywhere I like. So I'm just going to put that there. 45 degrees is there. I've got I guess I got about maybe 120 field of view, which is good for human vision. And let's say on my canvas that distance is 6 inches. And I can just make that whatever I like. If I'm doing a mural, it might be 30 feet. If I'm doing, I'm painting a stamp, it might be 4 millimeters. I could measure it in pixels. It doesn't matter. You just have to know the distance out to 45 degrees. Lastly, I want to know what's the angle to the thing I'm measuring, to my target. Now in my case that was really easy because I was trying to find the compass bearing. So I knew I wanted to know the distance out to 22.5, I wanted to know the distance out to 67.5, and that's going to depend on what it is you're trying to work out. Anyway, enough of this. Here's the formula. The distance from the center of my picture to my angle is this distance here. The distance is equal to tan, which is a trigonometry function, tangent of the angle times the distance to 45 degrees. It's really simple. So if you don't know what tangent is because you either didn't take trigonometry or you haven't taken it yet or you can't remember it like most of us, you don't have to know. You can just use your handy dandy calculator. And here it is, the Windows calculator. Yours might look different. You'll need to make sure that it's in scientific mode. And then you'll see a little function here, tan. And this is the basis of everything we're going to do. So let's say from my picture, oops, lost control of my mouse there. From my picture, here's my scene. Got a nice wide one. Here's the center of my picture, and I'm going to say my angle out to 45 degrees, my 45 degree cone is going to be, what did I have before? I had 5 inches. So if I want to work out how far out is it to, so this is going to be 5 inches, this is 0 inches, and 45 degrees in the other direction is going to be minus 5 inches. So if I want to know where does 22.5 degrees, what I do is I take the calculator, I type 22.5, I take the tangent, and I multiply by 5 inches, and I get 2.07. So that tells me if I go to the right 2.07 inches, that's exactly where I should find northeast. If I want to find northeast, 45 degrees, then I already know that one. It's 5 inches, but let's work it out again just to prove that it really does work. Got my calculator. I take an angle of 45 degrees to the right. I take the tangent and I multiply by 5 inches and I get 5. So it does work. If I want to do 67.5, which is east-northeast, I take the tangent and I multiply by 5 and I get 12.07. So that was 5 inches, and east-northeast, which is 67.5 degrees, equals 12.07 inches, which is pretty close to 12. So let's make a scene using those numbers. So I'm going to turn the grid on. Here's my horizon. This will be north. So that is 0 degrees. And I know I can't put east on my drawing because that's 90 degrees east, and that would need an infinitely large piece of glass. But if I go, I've set my field of view to be 5 inches. 5 inches for 45 degrees, which is northeast. Then if I can remember from before, 2.07 inches is where northeast should go, and 12.07, just about there, So you can see this matches what I said before. The further I get from the center of my picture, the further apart these angles become, even though each of these steps is a constant change in angle. So now I'm going to do the same thing on the other side. There's minus 22.5. That should be 22. There's minus 45, which is northwest, and and a bit is here. So this is west northwest, which is 315 or minus 45 degrees. So now I'm going to rebuild the paths. So what's cool about this is that I can actually fix the sizing problem I had before. If I lay down, like in typical one-point perspective, a view straight down the path, now that I know, if I'm looking down on this scene, you know that a 45-degree angle creates a perfect square. So I can just come in from 45 degrees to the east, 0 plus 45, and this is going to be a 45-degree angle cutting across my square. So I'm going to draw my square from there. So that's solved one problem already. Draw the other one out to there. And skip that. So now my path heading northeast looks like that. My path heading north by northeast looks like that. And my path heading all the way out here looks like this. And then, as before, straight east looks like that. Straight west. Oops. So when I zoom in to match my field of view, this looks kind of like I'm looking out from a rosette in a garden. So that's been very helpful. So, okay, now of course doing all these calculations is kind of a pain in the butt. So what I did was I wrote a little program to create some guides for me so I didn't have to do it each time, and I've got that saved as a brush. And the brush looks like this. So here I don't have to do those calculations again. If I want to do, this is the center of my picture right here. Oops, I'm still on my wacky brush. This is the center of my picture. And if I want to go 45 degrees to the right, I will put my vanishing point here, my other vanishing point here, oops, at minus 45. Now, if I wanted to do an angle, so this is a right angle because these are 90 degrees apart on my little guide here. If I want to do something that's rotated 10 degrees from that, that's really easy. I'll just switch to red, and I'll just add 10 degrees, and I'll just subtract 10 degrees here. So that's what that angle looks like, rotated 10 degrees. If I want to rotate it another 10, I just come in like this. So there you have it. So this works basically if the guide is level with the horizon. My next video, if I can get to it, I'm going to explain a little bit about looking up and looking down because some really interesting things happen with angles. But I've put this guide up on DeviantArt, michaelprescott.deviantart.com. So I hope this was useful. You can download it and do some of your own experimenting. And if you have any feedback, please fire away. And thanks very much for watching.